Alright, well, welcome back, and today we're going to be talking about how to find two exact solutions of each equation, give answers in degrees and radians. But in this case, we're going to be using a calculator. So I got my calculator up here, and we're going to be going through and trying to figure out some of those cool strategy neat stuff. Okay, so without further ado, if you saw my other videos on how to find two exact solutions, you know that it has some certain criteria. First off, one of the things that we always want to try to do first is we want to make this into sine and cosine because we're going to be using what are known as the inverse trig ratios in this. And all these inverse trig ratios that you find, and I'm just putting all these out here, right here, are all either sine, cosine, or tangent. So you can't find out any other ones any other way. So first off, we have cosecant. And cosecant is 1 over sine of theta, which we know is negative 6.125. So we're trying to find this angle. This is our ratio. Right here, this is not a common ratio that we know, so it's not going to be a 30-60-90 or 45-45-90 or anything like that. And so what we're going to do is we're going to put this in sine or cosine. In this case, it's going to be sine. And we're going to flip this, so I have sine of the angle is going to equal 1 over negative 6.125. Now, I want to find this angle, all right, right here. And if I do that, I'm going to take the inverse sine, because if I take the inverse sine of both sides, we can use the inverse property, and these will cancel out and give me theta. Boop. And then I take the inverse sine of this side, all right, and I'm going to take this as negative 1 over 6.125. Okay. And let's do this one in degrees. We're going to do this one in degrees. So make sure your mode right here is in degrees. I'm going to go down here. Make sure my mode is in degrees. Boop. All right. Quit. And then we're going to take second sine, inverse sine of negative 1 divided by 6.125. All right. And press enter. And what do we get here? Well, we get an angle of negative 9.396 degrees. So what does that mean? Well, what that means is that if we draw our little graph right here, we have to figure out now what quadrant are these two angles in, because we're trying to find two angles. Well, sine is negative because this ratio is negative. Well, sine is negative, sine is y, if you recall. And that's going to be down in either the fourth quadrant, that's when sine y is negative, and in the third quadrant. And so this angle we found is actually negative 9.396. And we want to figure an angle, and I didn't say this before, but an angle between, all right, 0 to 360 degrees, or the angle wants to be between 0 and 2 pi. Okay, and so right here, our first angle is actually going to be this angle. We'll call that angle 1. And then we have another angle all the way around, which is going to be angle number 2. Negative 9.396 is not an angle, all right, of what we're looking for, a positive angle. So how do we find this? Well, we can use this because actually we can make this into a reference angle. This is a reference angle. If we get rid of the negative, we actually know this angle right here, this reference angle, is going to be 9.396. And this same thing is going to be the same reference angle over here. And so I'll put that right there. We have the reference angle here and here. So how do we find the remaining angles? Well, if you go over here and find angle 1, we see that angle 1 is 180 degrees plus the reference angle, which is 9.396 degrees. And so we can take that right there, 180, all right, plus 9.396, and you probably can just figure this out of your head, because it's going to be 189.396, all right, degrees. We can convert this into radians by taking that and multiplying it by pi, all right, divided by 180. And our radian measure is going to be approximately, all right, 3.306, okay? And that is in radians. Next thing is we want to figure out what is our second angle. I'm going to push that down a little bit more. Okay, and so our second angle, you notice, is going to go all the way around here, and it's going to be in the fourth quadrant, but you notice that it's going to be actually 360 degrees, and we're going to subtract the reference angle at 9.396 degrees. So if we take this 360 degrees minus 9.396, and what we have is 350.604 degrees. Okay, and once again, if we take that, multiply that by pi, divided by 180, we can actually get our radian measure, which is or 6.119, all right, radians. And that's how we figured out how to find those two angles with our calculator. Okay. Well, we could try another one if you want to try this yourself. You could try this. You can pause the video and try it out, but I'll go through it right now. This one, once again, we want to convert this into sine and cosine because we can't do that any other way. So what we're going to do is we realize secant is 1 over cosine. And so right here, we have 1 over cosine of an angle equals negative 4.156. And so cosine of this angle is going to equal 1 over negative 4.156. And if I want to find the angle, that means I need to take the inverse cosine. Because remember, inverse cosines, inverse sines, inverse tangents give you angle measurements. Okay, so make sure you do that. And that's where we go there. So over here, we're going to do some degrees again. We're going to have second cosine, all right, of negative 1 divided by 4.156. If I did everything right, you're following along. And so we find we have an angle measurement of 103.923, or if I round that, degrees. Okay. Question, what is that angle? Is that an angle we're looking for? So let's go over here and find out where this quadrant could be. Well, cosine, where's cosine negative? Cosine is negative. Well, remember, cosine is x, y. So cosine is positive in the first quadrant, but negative over here in the second quadrant, because that's when x is negative, and also over here in the third quadrant, because that's where x is negative as well. Fourth quadrant is where x is positive, so it wouldn't be that. So we're looking for this angle measurement right there, angle 1. And we also have angle, and angle 2 right there, going away to the third quadrant. So what do we get here? Well, when you take the inverse cosine, if you looked at some prior videos or you know anything about inverse cosines give us angles in the first and second quadrant. And so that actually helps us out because we know by looking at this is that our first angle, just by doing this one, this is actually angle number 1. That's angle number 1. So that angle right there is 103.932 degrees. So how can we find angle number 2? Well, there's a bunch of different ways of finding angle number 2. One way we could do is we could find another reference angle. So if you wanted to find this reference angle right here, okay, we could actually take 180, all right, minus that angle. If we just put our answer right there, and we could get our reference angle of 76.077. And you could find angle number 2 by taking 180, all right, plus 76.077. And if we did that, that would give us our angle in the third quadrant. And so we would have an angle of 256.077 degrees. If we wanted to convert these into radians, once again, like the other ones, we could take that and actually multiply this answer by pi. All right, and then divide by 180, and we can find that in radians and so on and so forth. Now, another way you could do this is that some of you might be thinking, well, maybe in my class, the trig teacher told me, well, why can't we just find this other angle? These are the same, so can I take 103.923 and subtract it from 360 degrees? Do I get that same thing? Well, let's try it out. 360 degrees minus 103.923, and I guess you're going to be pretty surprised, or not surprised, you get the same answer. So yeah, a bunch of different ways of doing the same thing. It doesn't matter because we're doing trig, and just as long as you identify what the angle is and understand that this is 180 horizontal, all right, and 360 is all the way around the circle. That's how you do it. You never take anything to the 90s because we always find reference angles to the horizontal. So either we're using 360 or 180. They're adding or subtracting to figure out what the quadrant, depending on the quadrant it's in. Okay. So going on to cotangent, we'll go one more time. All right, one more example for you. You can try this if you want to try it at home. You can try this as well. Okay. But going through this one right here, we know that we have to change this into tangent or cotangent, or sorry, sine or cosine. We know cotangent is 1 over tangent of theta, and that equals 5.671. We know that tangent then is going to equal 1 over 5.671. And so we can find our angle by taking the inverse tangent of 1 over 5.671. And we can go over to our calculator and take inverse tangent of 1 over 5.671. Press enter, and we get a angle measurement of 10.000 degrees. Okay, so 10 degrees. Well, where is this? Where does this help us out? This is the reference angle we can use. Well, tangent. Tangent is y over x. So really we have, we're looking for it's positive, right? Because this is positive. Well, y is positive in the first and in the second quadrant. X is positive in the first. So positive over positive makes positive. So that makes sense. So our first angle that we're looking for is actually a reference angle we can use, and that's going to be 10 degrees. We can then go over here, and where is the second one? Well, positive over negative makes negative. We don't want that. We have a negative over a negative, which makes it positive. So yes, the third quadrant is where we're going to have tangent being positive as well. And so we know that these are vertical. So our reference angle right here is 10 degrees. If I want to figure out the second angle, what we want to do is take the second angle, and because it's in the third quadrant, we're going to take that reference angle and add it to 180 degrees. And what we have is 190 degrees. And I'm just going to add that because it's 3 decimal places. All right, 190 degrees. And if you want to take 190 degrees and put in the radians, or any of these, once again, you just take those 10 times pi divided by 180 degrees. Bada bing, bada boom. All right, so we can find this one is 0.175. All right, radians. We got that. Point. All right, and we can go the same thing there if we wanted to. I'm just going to stop. All right. So I hope this helps you out. And how to identify finding the two exact angles. And I'm just finishing this up as you can see them over here. And so yes, that would equal 3.316 radians if we wanted to know the other one. All right, but yeah, key thing once again, all right, put this in sine, cosine, or tangent. All right, use the inverse trig ratios to figure out a potential reference angle, depending where the reference angle is. Figure out the quadrants. What angles are you looking for? What two exact angles are you looking for? One might be in the first, second, third, fourth, wherever it is, depending on what the ratio and the sign of the ratio given. Okay? Well, I'll just help you out, and good luck and God bless in the rest of your problems.